of the photons at a rate of 0.1 watt. Of the photons given out, 0.15% fall on the cathode of a photocell, which gives a current of 6 microampere. Find the energy of photon, find the number of photons leaving the source per second, find the percentage of photons falling on cathode which produce photoelectrons. Try to read this. So what is everything? This one, this is the photocell, emitter, light is incident, power of source, there's a lambda, there's an emitter, this is a collector. Is it every incident photon will produce one photoelectron? The answer is no. There's some efficiency there. The efficiency parameter will come into picture. No, get into this one. And a current I will flow. So this current is what is telling. Power of source is given. Energy of photon is given. Called that is F. He's talking some sort of that 0.15%. There's a very basic theoretical idea. I just made it as a question here. First, we'll go for every 100 photons, so it depends 0.15. So what is telling? Of the photons given out, 0.15% fall on the cathode. How many fall on the cathode is what needed, no? Number of photons falling on the cathode, that has to be determined. First of all, how many photoelectrons are generated can we calculate by the current? Because what is the current? Current is equal to number of photoelectrons into charge of electron. What is any? Number of photoelectrons emitted by emitter. So we know current is how much given? 6 microampere. So 6 into 10 to the power of minus 6 Ne. So this is 1.6 into 10 to the power of minus 19. Shall I say emitted by emitter per second? All these are per second. C plus 13 it will come. So these many photoelectrons are ejected by the emitter per second. Okay, now after getting any, what is that percentage? 0.5% is asking find the percentage of photons. So next after this, what we have to do? How many photons are emitted by source per second we'll calculate. For that we know power of source and frequency. I'll come to the next here. Ns. What is Ns? Number of photons by per second. So that should be equal to power of source by energy of photon. So this from this what happen? We'll get the Ns value. Now, is it all these emitted photons? Will they strike? I think it's the diagram. It's very easy. No, you can see this. This will emit light in all direction. In that what happen? Of all emitted, only few will fall on the emitter. No, I think the diagram itself will speak a lot. Very easy for you to understand. So what is telling? Of the photons given out, 0.15% fall on the cathode. So shall we calculate now? Number of photons incident on the emitter or this called like a cathode. Number of photons incident on cathode or emitter. Ni I'll call it. How much it should be? 0.15 by 100 into ns. What we know ns from here, that you substitute, you'll get ni. And now is asking, now we know ni, these are incident and these many are produced. Number of photons incident in cathode and these many electrons are produced. So can we calculate now? uh, Find the percentage of photons falling on cathode which will produce photoelectrons. Is asking that particular efficiency, no? How to calculate efficiency? Ne by ni or ni by ne? Ne by ni, no? For these many incident photons, how many photoelectrons are generated? So the efficiency will be a very good problem. Just is telling that just very general way of asking things here now, because all the photons emitted by source will not fall on the cathode. Next, all the emitted photons on the cathode will not generate photoelectrons. That's what the theoretical ideas he has made that as a numerical here. And 9% it will come efficiency. Check it. I'll go for next one.